Welcome to this feed scroll generator tutorial for Autodesk Inventor. This time we're looking at how you can clean up the geometry of a 3D bottle that you may have received from a supplier or you may have downloaded from somewhere, and prepare that geometry for use with the feed scroll generator app. We're going to be looking at why this particular bottle I've downloaded from GrabCAD is not yet suitable for use with the app, and how we can use the native Inventor tools to clean it up and make it suitable for import into the feed scroll generator app. For this bottle, what we're after as a finished result is something like this. And if you look at the differences between these two bottles, you should be able to see where we're going with it, and we'll go through step by step to get to this after result. But before we jump into that, let's just do a quick checklist of things we need to be aware of if we're importing 3D bottles. Firstly, most importantly, there must not be any sharp edges on the bottle that come in contact with the shaft. It's okay to have sharp edges on the bottom or the top, because that's unlikely to actually come into contact with the shaft itself. So that's point number one, no sharp edges. All faces must be tangential to each other. Secondly, no small raised or engraved features, like for instance if I switch on this embossed text here. Hopefully you can see that trying to cut this text in a shaft would lead to no end of problems. So we need to make sure that the geometry, if you do have this kind of geometry on a imported bottle that you want to use with the app, then what you'll need to do is to use a delete face command, and then you can drag a box around all of those faces, hit Control to remove the ones that you don't want to delete, and then heal remaining faces, and you can say OK and attempt to remove those small faces in that way. The same would go for any small holes or anything like that in the bottle. These all have to be patched up using the surfacing tools. Okay, what else? Number 3, we need to make sure, of course, that the bottle we want to use is not hollow. We need to make sure that we use some of the Inventor tools to actually fill up any hollows inside the bottle, and we'll do that as part of this exercise on this bottle as well. Fourthly, you may find that sometimes you need to actually chop the bottle in half and remove the portion of the bottle which is not going to come into contact with the shaft. We're actually going to do that at the end of this video, but if the shaft was over here, we may need sometimes to chop the bottle down the middle here and actually extend the bottle out here to remove the need for Inventor to calculate the geometry for all of the back side of the bottle here. We do actually not need to do that in the case of this bottle, but we do it anyway at the end of this video as an example. Okay, let's get started on simplifying this bottle down to this finished result. So first off, we definitely need to remove this unwanted geometry at the top and bottom. This is only going to make the app's job more difficult, and this geometry is not even coming into contact with the shaft. So I'm going to pick this geometry here. I'm then going to also, if I switch to the right view, I'm going to hit Shift and select this geometry down here as well, and then I'll use the delete face tool. And I'll say I do not want to heal the remaining faces, and say OK. So that's looking a little bit cleaner now. I now need to patch up the top and the bottom. You can see we've got an inner and outer skin here. We don't need to worry about that because we're going to sculpt the whole thing into a new solid anyway. So I'm going to use the patch tool and just patch up the top and say apply. And then I'll do the same on the bottom. Pick the outer surface and hit OK, and then I can just sculpt this into a single solid, which will get rid of that inner surface there for me, which I don't really want. So I'll say sculpt top and bottom patches and just say OK, and now we've got a single solid body here. We do still have these surface bodies, but that doesn't matter, we're interested in the solid body. So that was the easy job. The next job is, what do we do about the sharp edges that we've got on this bottle? How do we know we've got sharp edges? If I double click on this surface, you see it only selects the tangential faces, and it's not selecting this geometry here because we have a sharp edge running all the way down here. Again, if I double click here to select the faces, the inside pocket here is not selected. So we need to make that edge not sharp Could we do this with a simple fillet? Let's have a go. If I click fillet here and start selecting the edges, you can see Inventor's going to really struggle to add a fillet on there. We've got some quite unpleasant geometry going on around here. We're not going to be able to successfully put a fillet on those edges, so we need to use some surfacing tools to improve this. The method I want to use is to use this existing surface to create some construction geometry, which we can then use as a guide for the new boundary patch that we're going to create on top of it, and then delete these unwanted surfaces. So let's have a crack at that. I'm going to change my view here. I'm going to start a 3D sketch to reference the existing face to create this construction geometry for my new face. So we start 3D sketch. Now we've got a very handy tool in here, introduced I think in 2016 or 17 version of Inventor, which is curve on face. And if I pick this one, what I want to do is to draw a series of curves on this face that can be construction geometry. So let's just start drawing maybe one here. I'm going to try and make these vertical curves. Let's hit space to start again, but it's not essential that they are completely vertical curves. Let's hit OK there, and spacebar to repeat. It's really just that we give a good covering of this whole surface in terms of construction geometry. So hit spacebar to repeat. Now I want this one to be in the center though, because I do want the whole thing to be symmetrical. So what I'm going to do there is I'm going to hit escape. Let's turn on the plane. Let's hit escape and turn on this plane here. Right click visibility. And then I'm going to use a coincident constraint between this plane, this point and this plane, and then this point and this plane, because I do want that to be perfectly in the center. And then I want to mirror these lines because I do want the whole thing to be symmetrical. So I'm going to use the mirror tool, pick this point, this point, this point, this point. And then the mirror plane is this plane. And then I'll say apply and done. And then I have to draw the curves again. I can't actually mirror the curves in this case, but let's say OK. Spacebar to repeat. Spacebar to repeat. Okay, so let's take a look at that geometry. If I spin this round, you see those curves are on the face itself. So that's probably quite a good set of construction geometry to use as a guide for my new surface. So let's right click and turn off the visibility of that plane. Let's save the part maybe. And let's get rid of the original geometry. Use the delete face tool again. So I'm going to select all this geometry here, which will pick my geometry front and back for that pocket. I'm going to use the delete tool. I won't heal the remaining faces, and we've gotten rid of that geometry there. Okay, I haven't put construction geometry on the back here because I don't really care about the shape of this pocket at the back, because it's not going to come into contact with the shaft at all. So I'll just use the default pocket geometry for that. And then I can start the patch tool again and pick this loop of edges. And now you see why we need our construction geometry from the original face. This boundary patch is going to be nothing like the original face unless I use these curves as guide rails for the boundary patch. Okay, so let's first off actually let's say that we do want it to be tangent or smooth even better to the original face. So there you go. Now we're going to have a nice smooth edge here. And then I need to apply my guide rails. So watch what happens as I pick these guide rails here. Let's pick this one. And you see the whole surface is now being pulled into shape. Okay. Now if we look sideways on, you can see that this is now a very good approximation to the original surface that we had. Obviously the more construction geometry you put in, you can use curves, you can use points there, you could use some actual proper curves rather than straight lines. The better geometry you have, the more geometry you have to guide the surface, the better the finished result will be. This would be good enough for our example now, and I'll say OK. And there we've got our surface, which you can see is very close to what in fact the original surface was. And we want one on the opposite side, but it doesn't need to be accurate. So I'll pick this one and I'll just leave it like that, in fact, because I don't need it to be accurate at all. Okay, and then I'm going to use the sculpt tool again, pick the solid, pick those two surfaces and say OK. And then I've got a construction solid here. Now if we look carefully at this geometry, you can see there's a little bit of some ridges involved here. This is not 100% smooth because of the kind of construction geometry I've used for the rails. I think using an array of points there to control the geometry, or some better construction curves, would improve this, but this is good enough for our example. Okay, so let's save this part, and I'm going to close it and then open up my empty new part here, and I'm going to import that solid body as a new bottle shape. So I'm going to hit generate on the app. Let's go straight to importing the 3D solid down here. Let's pick that bottle solid. That was bottle 3. I think we've only got one solid in this part now, haven't we? So let's rotate. And we need to be careful that we put it in the right way round. That's the wrong way round, isn't it? Because we've got a good pocket face and a bad pocket face. Let's use the good one. So let's flip that around. That's better. And then the height of it, remember, we can control with this one. So I'm going to move the bottle up till it's about there. That looks like a sensible place for the shaft to push the bottle along with relation to its center of gravity. Okay, and I will say OK to that, which will then import that solid body permanently into this part. And I might just save this part at this point. Let's call this bottle. Actually, yeah, let's use that name there, bottle cleanup example. Well, we clearly need to do some repositioning of this bottle to get a shaft that looks sensible, so I might make the shaft length maybe slightly longer. I need to move the bottles further away from the shaft center with this one here. Let's maybe try 95. That looks about sensible, doesn't it? And obviously the pitch of the bottles is going to need to be more. I forget exactly what size this bottle is. Let's zoom in here. It looks like it's going to be 99 or so. .5. Okay, this is good enough for this example. Of course, we need to make sure we've got enough distance at the start that is 99.5 and enough distance at the end. Let's make the pitch at the end maybe 140 millimeters. And that's looking like a pretty sensible shaft design for us to try out now. Okay, so let's save the part. And we definitely do want to run a preview build now. The reason for that I'll explain as this preview build is running. With more complex bottle 3D imported shapes like we've got here, any waviness or any irregularities in the bottle shape with that boundary patch that we drew onto the bottle, for instance, is really exaggerated and amplified in the background geometry that the app uses to construct the smooth loft surfaces. So if it's been exaggerated too much, then we have to go and improve the construction geometry that we've used. This preview build, as you can see, takes a bit longer because the complexity of the solid is greater, but it looks like that's finished, just creating the final solid body now. So we'll see how wavy this geometry is. A bit of waviness doesn't matter because of course the app works to smooth that out without actually impacting the accuracy of the finished solid body. Let's just say we don't want to continue with another operation here. This actually looks pretty good. This kind of waviness is totally fine and totally normal, and it looks like if we double click on one of these edges, for instance, Yeah, so it's a nice smooth edge. The app will be able to manage this kind of sharp edge here totally fine. Okay, so let's hit generate again and we'll get ourselves ready for doing a full smooth build now. I think we'll be okay to leave these profiles and rail sliders as they are. We don't need a lot of loft profiles for a small amount of shaft revolutions like this. Now I'm going to hit go on a smooth build, and what we might find is that okay, so we found that the app, or rather Inventor underneath, is struggling to perform the main boolean between the bottle and the shaft. This is because we actually perform that boolean in very, very small increments, tiny increments in fact, and the geometry is incredibly complex for Inventor. But we have the settings available in the app to increase that increment, and therefore we can allow Inventor to calculate it without impacting the finished accuracy too much. You'll see what I mean when we take a look at the accuracy of the finished shaft in a moment once we get this to build. So I'm going to say OK to that, and the instructions in there were to go and hit this advanced parameter settings, and this is the profile tolerance value that we need to increase. So I can try something like, let's try something like 0.3 instead of 0.01. And let's hit generate again. We might find that we need to increase the increment even more, in fact, in order for Inventor to be able to calculate the booleans. It looks like it's making more progress this time. It's taken 35-40 chunks of the bottle out of the shaft, so it looks like it may be okay, but the geometry might get more complex as it moves along over here, so we'll have a look. I'll speed the video up just in case. Okay, so it looks like it's gotten about halfway this time before having some trouble with the booleans. So let's say OK, and let's go and increase that value a bit more. So maybe make that 0.5, save the part, and hit generate again. Okay, so that shaft's created fine this time with the adjustment to the advanced parameter down there, about 3.5 minutes. Let's say I don't want to continue with another operation. Actually, I should have hit yes to that because I want to run a simulation, and I want to check the fit between the bottles and the shaft, as I said. So let's hit the simulation button down here. Okay, and we can see the movement of the bottles as usual. Check the other videos for the examples of what we can do in the simulation here. What I'm really concerned with at this point is the fit between the bottles and the shaft, because we did increase that parameter number from the default of 0.01 to 0.5, so quite a big increase there in order to be able to get these booleans to work. So let's take a look at that. So I'm going to hit view, half section view, and click the top of the bottle, and then let's drag this down. Let's take a look. So we can pick one of these bottles in the center here and take a look. So we're expecting maybe a slight clash between the bottles and the shaft. Actually, that looks pretty good. Okay, so this is Inventor's rendering here rather than an actual clash between the bottle and the shaft. Actually, let's maybe have a look at this one over here so that we don't get that plane in the way as well. That's a bit better, isn't it? Okay, so you can see that this is interesting here. You see that the fit is effectively perfect there between the two again still. We've got slight clearances here, but then this is it's a clearance at one point, but it's not a clearance at another point along as the bottle rolls along the shaft. So take this point for instance, you can see we've got effectively a perfect fit. Okay, so don't if you're using more complex bottle shapes like the one we've got here, don't be frightened to increase that parameter value. You see the default is 0.01 for the profile tolerance parameter value. You can increase that up to 0.5 with no real detrimental effect to the accuracy here. You can increase it even more if necessary. And then if you need to use the bottle oversize tool in order to provide a small amount of clearance for the bottle, then you can do that. Check out the other tutorial for an example of how to use the bottle oversize. Okay, but you can see here that the bottle fit to the shaft is effectively perfect. Will be tiny fractions of a millimeter involved in differences there. Another tip that might help you out if you're working with more complex 3D imported bottle shapes like this, what you might need to sometimes do is to chop off half of the bottle and actually extend the bottle shape out here, because what can happen if the bottle's buried quite deep into the shaft, the back of the bottle can also be in contact with the shaft, and that can make the calculations just more complex. I'll show you how we can do that. In this case, if we didn't need to do it, but I'll show you how you can. So don't extend the bottle before you import it using this 3D import tool. Extend it afterwards once it's imported. So this is the point we would want to extend that bottle artificially out the side. So the way we do that is exit out of the app but remain in this part, and then start the plane tool. And then I just want a plane that's in the center of the bottle really, so because I'm not 100% sure of the positioning of this bottle, I'm going to draw myself a plane down the middle. It's important that it is exactly down the middle there. And then I'm going to use the split tool up here and pick the plane for the split tool, pick the solid that I want to split, which is the bottle, and choose the bit that I want to remove, which is this bit here, this side, the outer side. And then I want to extend that, so I'm going to left click here and hit create sketch, and then project in the geometry, the entire perimeter of that face. There we go. And then I'm going to finish that sketch and extrude this, so you can hit E on your keyboard or use the extrude tool up here. Okay, and it doesn't really matter how far we extrude this, it just needs to be far enough out to be clear of the shaft really. So let's make that 60 millimeters, and then turn off the display of this plane. Right click V on your keyboard will do that. And then if I save this part and hit generate again, you can see now we have no possibility of the back side of the bottle, this side, causing any further complication to the geometry because it's all nice and smooth. Extending the bottle is sometimes a good idea if you're not getting the build to work with the true bottle shape. Okay, so let's exit out of here. And there's our finished shaft design. If you made it this far again, thank you very much for watching and have an excellent day.